Hi, welcome to binary tree preorder traversal without using a recursion. Here we are using the iteration using the stack. First we will create the stack. So stack is created, then we will check the root equal to null or not null. If root equal to null, the tree will be empty. So we are simply return nothing. Then if it is root available, then push that root into the stack, then repeat while the stack is not empty, popping the element. Then for that current element we have to check the right child. If right child is available, push that right child into the stack. Then check the left child for that current node which is popped up. If it is available, push that left child into the stack. Then we will repeat the iteration while the stack is not empty, and while until the stack is not empty. We will see the example now. Here just we are creating the class preorder and creating the node root. Now we are calling the method root. Essentially we are checking root is available or not. So now the in this given tree root is available, that is the one. If root is available, then this statement will not execute. Now we are creating the stack. Yes, stack is created here. Then once stack is created, the root is entered into the stack, so that is pushed into the stack. So now one is pushed into the stack. Once one is pushed into the stack, we are checking iteration. Stack is not empty. Yes, it is not empty. Why it is not empty? The element is popped up. So one is popped up now, assigned to the temporary. So once one is popped up, then it will be assigned to the temporary. So now temporary is having the value 1. Now the which is printed temporary dot value. So actually temporary in the sense it will have the three fields: left field, data field, and right field, right? So in the data field which is having the 1, so 1 dot value is printed now. So I am printing the preorder is 1. Then we are checking temporary dot write not equal to null. Now the temporary is 1, so 1 is the temporary. Now 1 dot write is not null. Yes, it is true. So once it is true, push that temporary dot write into the stack. So now 3 is pushing into the stack. So 3 is pushing into the stack. So next we are checking temporary dot left not equal to null. Yes, temporary dot left is not equal to null, which is having the 2. So which is true. So 2 is pushed into the stack. So 2 is pushed into the stack. Now again we are going back the stack. Yes, checking empty or not empty. Not empty, so which is true. Then once it is true, we are popping up the elements. So stack is popping up the element. So now top of the element is 2, so 2 is popped up. 2 is popped up. Then the temporary is now having the 2, that is assigned to the 2, printing the temporary value. So now previously 1 is printed, now 2 is printed. So 2 is printed now. Then we are checking temporary dot write not equal to null. So now this is we are checking temporary dot write. Temporary dot write is yes, which is not null, so which is having the 5. So now we are having the 5. So 5 is pushed into the stack. So 5 is pushed into the stack. Then we are checking temporary dot left. Temporary is now 2, right? Temporary is now 2. So 2 dot left. 2 dot left is now the 4. So 4 is inserted into the stack. So 4 is inserted into the stack. Again we are checking the stack is empty or not empty. Yes, it is not empty. So now we are popping the top element. So top element is now 4. So 4 is popped up. So 4 is popped up, assigned to the temporary. Then printing the temporary value. So temporary value is 4, now printed. Then we are checking temporary dot write. So 4 dot write. 4 dot write is actually null. So if it is null, the condition is false. Condition is false. Then it will not execute. Now temporary dot left. Temporary dot left also 4 dot left also null. So this is also false. So condition will not execute. Now again we are checking the stack. stack is empty or not empty, not empty. So if it is not empty, we are popping the top element. So top element in the stack is now 5. So 5 is popped up, 5 is popped up. So 5 is popped up and assigned to the temporary. So now temporary is having the 5, printing the temporary dot value. So 5 is printing here. Then now we are checking the temporary dot write. So 5 dot write, which is null, so this is false, not executing. Temporary dot left also here null, so which is also not executing. Now we are again checking the stack. Stack is not empty, yes it is true. Stack is having the element 3 now, right? So now popping up the 3 assigned to the temporary. So popping up 3 and assigned to the temporary. Now printing the value of temporary, so that is printed. Then we are checking temporary dot write not equal to null. So here 3 temporary dot write not equal to null, yes, which is false, so which is not executing. Then temporary dot left is checking. So temporary dot left we are having the 6. So this is true, so it is true. So we are inserting the 6 into the stack. So now already 3 is popped up in this step, so stack will be empty now. So now it is 6 is inserting. So instead of so 6 is inserted in the bottom of the stack, because now all are empty. So now we are going to insert the stack, 6 into the stack. So now 6 is there. Again we are checking the stack. Again we are checking the stack. Stack is empty, no it is not empty, 6 is available. So it is true, not empty is true. Now popping up the element. So popping up the element is 6. So temporary is now 6. Then printing the pre-order value here, temporary dot value. Now checking temporary dot right not equal to null, which is false. Then temporary dot left not equal to null, which is also false. So both are null, so it is false. Again we are checking stack is empty, yes it is empty. You look at that, once it is popped up in this location, stack will be empty. So now we can stop the algorithm. Here we are visited all the n number of nodes in the tree. So the time complexity is order of n, and also we need n number of locations to store the values. So the space complexity is also order of n. Thanks for watching.